Welcome for today's class. In today's class, we will be discussing about the next group of instructions, program control transfer instructions. So, these are the list of the instructions that we are going to discuss in this. The first instruction is jump on 0, jump if equal, JZ, JE. So, JZ jump on 0, JE jump on equal to the address. So, in this particular these are the conditional instructions, conditional jump instructions. So, for these jump instructions, what will be done is the program sequence will be deviated from current sequence to new sequence. So, for that we will be using either conditional or unconditional jump instructions. So, when we are using the conditional jump instructions, the condition will be verified. If the condition is satisfied, then the sequence will be deviated from current sequence to the new sequence. The new sequence will be specified with the address along with the jump instruction. If condition is not satisfied, then the next instruction in the current sequence will be executed after the present instruction. After the jump instruction, the next instruction in the current sequence will be executed if the condition is false or not satisfied. So, that is about the conditional jump instructions. If condition is satisfied, so sequence is deviated from current sequence to the new sequence specified by the address with the jump instruction, and if the condition is not satisfied, then the current sequence will be continued after the jump instruction. So, we will see some of the conditional jump instructions. The first one is jump if 0 or jump on equal. So, JZ, JE. So, in this particular case, so jump on 0 and jump if equal to the address. If the condition is satisfied, jump on 0 means, so before this instruction we may be using some other instruction. So, generally for jump on 0 or jump if equal, jump on 0. So, previous instruction, if the result of the previous instruction is 0 or if the 0 flag is set, then that will be taken as condition for this instruction. That is taken as condition for this instruction. So, in that case, the condition is satisfied, go to this address and continue the new sequence from this address onwards. If this condition is false, then continue the next instruction followed by jump on 0. So, jump if equal. So, if generally if this instruction is, say for example, any comparison, if it is a comparison, so equal or not equal, then this we may be using. Even if the comparison both are equal, again the 0 flag is set. Okay. So, 0 flag is set because when comparison, so generally quantity 1 and quantity 2 are being subtracted from each other. If both the quantities are equal, then subtraction result will be 0. So, based on 0, 0 flag is set, then the same jump on equal. This is how. So, this any one of these instruction can be used depending on the requirement. Okay, that is jump on 0. So, here the 0 flag, if the 0 flag is 1, then the condition is true and the sequence will be deviated from current sequence to new sequence, the address specified from this, that is jump on 0. Next is second instruction is jump on non-zero, jump on not equal. So, here also the 0 flag is being verified. If the 0 flag is 0, that means non-zero. If the result is non-zero, 0 flag will be 0, reset. If the result is 0, 0 flag is set. So, if the result is non-zero, then 0 flag will be reset. If the quantities are not equal, the 0 flag is reset. So, resetting of the 0 flag is called, condition is satisfied for this, then whatever address is being specified. So, the new sequence will start from that address, that is jump on non-zero. Next instruction is jump on sign flag, jump on sign flag. So, here the sign flag will be verified. If the sign flag is 1, that means if the result, so before this JS instruction, whatever instruction we have, if the result of that is negative, then sign flag will be set, then that flag will be verified by the jump on sign to the address. So, if the sign flag is set before instruction result based on the result of the before jump instruction, if the sign flag is set, then condition is satisfied. So, jump takes place to the new sequence, the address specified at the jump instruction, that is sign flag. Next instruction is jump on no sign. So, again the address, here also the sign flag will be verified if the sign flag is reset, that means if the result is positive, if the result is non-negative. If the result is non-negative, then the sign flag is reset, then that will be taken as condition satisfied for the JNS jump on no sign. Then sequence will be deviated to the address specified with the jump instruction, that is. So, first two instruction 0 flag, next two instruction sign flag, and the next two instruction this JO jump on overflow. So, this meaning of this JO is jump on overflow to the address. So, here overflow flag will be verified. If overflow flag is set, then if overflow flag is set, then so condition is satisfied, then the sequence will be deviated to the new address specified at the this. So, overflow flag. So, when there is a overflow condition results because of the previous instruction, based on the result of the previous instruction, if that leads overflow flag setting, then the condition is true and the jump will take place at this point to this address, that is overflow flag. Then JNO next instruction. So, jump on non-overflow, jump on non-overflow to the address. So, here what we are going, again overflow flag will be set verified if the overflow flag is reset. If the overflow flag is reset, then that will be taken as JNO condition is true for JNO and the sequence is deviated to the new address specified at this point. So, next to this JO and JNO will verify the overflow flag as conditions. Next instruction JP or JPE. So, depending on the book we are going to refer, some books it may be specified, the instruction is specified as JP, in some books it is being specified as JPE. So, that is jump on parity set. So, jump on parity even. So, here the parity flag is being verified. If the parity flag is set, then so sequence is deviated to the address specified. So, with every jump instruction, the label or address is being indicated with every jump instruction. So, that is whatever is nothing but the address, new sequence, beginning of the new sequence is specified as address or label. So, if the condition is true, now the here condition is parity flag. If the setting of the parity flag is condition, so jump and parity or jump and parity even. So, then parity flag will be verified. If the parity flag is set, then the new sequence is starting at this point. So, next instruction is JNP, jump on non-parity. So, jump to the address if the parity flag is reset. If there is no parity, if there is no even parity, then it is. So, jump on no parity condition is used. So, now these two instructions are using the parity flags, and next two instructions will be using the carry flag, that is JB, JN, AE, JC will use carry flag the address. So, here JB, jump if below, jump if not above or not equal, jump if carry, jump if carry is there. So, that is the meaning of these three instructions. All the three are same, the function of all the three are same. Okay, for all these three cases, the carry flag is being verified. If carry flag is set, then so new sequence will be started at this address. Jump if below, that means before this instruction generally is a compare instruction. Compare operand 1 comma operand 2. Operand 1 comma operand 2. So, here if operand 1 is less than operand 2, that leads setting of the carry flag. Okay. So, that means if the operand 1 first quantity is less than the second quantity, if the first quantity is below the second quantity, then condition is taken as true, carry flag will be set. So, here JB means jump if below, that means the first quantity is less than the second quantity. So, below means not above, not equal, first quantity is not above the second or first quantity is not equal to the second. So, the same meaning in this, the jump if carry flag is set. So, when carry flag is set, when both the quantities are compared, if the first quantity is less than the second quantity, automatically carry flag is set. So, that is why jump if carry. So, that is why all these three instructions are used, any of these three instructions are used, the purpose of all these three are same. So, verifying the carry flag, if the carry flag is set, then condition is taken as true and the new sequence will be starting at this point. The next instruction is JNB, JAE, JNC, all the three. Again here jump to the address specified. So, JNB, jump if not below. Not below means may be equal or may be above. The meaning of not below means the quantities can be same or first quantity may be greater than second quantity. So, the next is JAE, jump if above or equal, jump if above or equal, that means not below, jump if no carry. So, here what is happening, again the same condition, compare quantity 1, quantity 2, operand 1, operand 2. If in this case, if operand 1 is greater than or equal to operand 2, not below means it may be greater than or it may be equal. So, in this particular case, the first quantity is greater than or equal to second quantity, then that leads carry flag reset. Okay. So, here this uses the carry flag resetting. So, carry flag reset means, so first quantity is greater than or equal to the second quantity. So, that is the condition verified at this point. So, for these three instructions, so compare is the before prior instruction used. Okay. So, in that case there can be these, any of these three can be used as the conditional instruction, either these three or these three. So, in these out of 10 instructions what we have in this particular slide, so it is using 5 conditional flags or 5 status flags: 0 flag, sign flag, overflow flag, parity flag and carry flag. All these 5 flags are called status flags, that is giving the status of the result, or they are going to be called as conditional flags because they can be used as a condition for performing any of the operations. So, based on that, so these 5 flags are being used. So, in the next we will see some other instructions. So, next is jump if below or equal. So, next is jump if below or equal, jump if not above. So, here also the carry flag only will be used. Okay. So, carry flag will be used, carry flag and 0 flag, both. Carry flag is set, 0 flag is set. Either carry flag is to be set or 0 flag is to be set. So, because when you are comparing, say operand 1, compare operand 1 with operand 2. So, if operand 1 is less than or equal to operand 2, if operand 1 is less than operand 2, carry flag will be set, and if the operand 1 is equal to operand 2, 0 flag is set. So, if any one of these two flags are set, that will be used as condition for this, that is jump if below or equal. The alternate instruction is jump if not above, not greater than means less than or equal. So, that is what is being used for this. Next is jump if not below or equal, that means jump if above. So, in this case carry flag must be 0 and 0 flag must be 0. Okay. Not below, not equal. Not below means carry flag is reset, not equal means 0 flag is reset. So, if both the flags are reset means here now operand 1 is greater than operand 2. Okay, when the comparison instruction, the result is jump if above operand 1 is greater than operand 2. So, in that case both carry flag is 0 and 0 flag is 0, that both the conditions are verified at this point. So, next is JL, jump if less than, JNGE, jump if not greater than or not equal. So, in the previous instructions JL, JB, JB jump if below, JL jump if less than, more or less both are same, but the thing is the JB above, below, they are being used for unsigned quantities, less than, greater than are being used for signed quantities. So, that is the difference between JB and JL. So, JB is for unsigned quantities and JL is for signed quantities. Okay. Similarly, JA unsigned, JG signed, JA unsigned and JG signed. So, that is how this same equivalent instructions, jump if less than or jump if not greater than or not equal. So, here again less than means carry flag is verified. So, that means operand 1 is less than operand 2, it is not equal, not greater than. So, that is the condition used here. So, the next is jump if not less than, that means not less than means may be greater than or equal. So, for this carry flag should be 0. So, the condition verified is operand 1 greater than or equal to operand 2, that is the condition verified for this. So, next is jump if less than or equal, below or equal, less than or equal. So, the similar the same these two conditions, whatever conditions we have specified, the same conditions, carry flag is 1 or 0 flag is 1. Carry flag 1 means less than, 0 flag 1 means equal. So, less than or equal, either carry flag is 1 or 0 flag is 1, any one condition is verified. If any one condition is satisfied, then the condition is true and sequence goes to the next address. Next, jump if not less than or not equal or jump if greater than. So, here not less than means carry flag is 0 and not equal means 0 flag is also 0, that is the condition verified. So, if both the conditions are false, both the flags are reset, then this condition is true for this instruction and goes to the address. So, this is how different conditional flags are being used, carry flag, sign flag, 0 flag, overflow flag, likewise for verifying the conditions before deviating the sequence to the new sequence. That is about the program deviation from the current sequence to the next sequence. The next set of instructions, call, return, I return, int on, overflow, int on. So, next is for procedures. When we are calling a subprogram from the main program, then we will be using the call and the address. When you are using this, so this call address, this instruction is used to change the deviation from current sequence to the new sequence if we want to invoke any subprogram from the main program, then we will be using the call instruction. So, call instruction is used to invoke a subprogram from the main program, that means again program deviation only, but here after the execution of the subprogram we have to return, we have to come back to the main program. So, when we are invoking a subprogram from the main program, the moment subprogram is over, we have to return, we have to come back to the main program. So, the returning is required in case of call instruction, whereas jump returning is not needed, simply deviate and complete. So, here deviate, complete, come back, complete the current task. So, that is the difference between call and jump instructions. So, when we are using the call instruction, calling subprogram from the main program. So, program will be deviated to the subprogram address specified at this point, and in the subprogram. So, if this is our subprogram, the last instruction is in the subprogram should have the last instruction return. So, when the last instruction is written, that is this return is should be the last instruction of subprogram. Then, so program sequence again deviated from the subprogram back to the main program. So, when you are using the call, that means when you are using the call instruction. So, at this point the next instruction after the call, the address of the next instruction after the call will be stored on the top of the stack before the program is deviated. Before the program deviates, so the next address of next instruction address after the call instruction in the main program, that address will be stored on the top of the stack before going to the subprogram address. Then once subprogram is over, the moment it executes the return instruction, again the processor will get the contents from the top of the stack back into the instruction pointer and code segment register, and the next instruction onwards will be continued. So, that is the use of return instruction. Then another is IReturn. So, return from interrupt. Now, so when we are executing any program, sometimes because of any interrupt in between, the processor may be stopping the current sequence and it may be deviating to some other sequence to serve the interrupt request. So, to serve the interrupt request, it has to execute some other program by stopping the current program. When it is executing the other program, the last instruction in the interrupted program is IReturn, that is return from interrupt. So, in that case, whenever any interrupt sequence is being to be executed, the processor will stop the current sequence and the address of the next instruction after the interrupt instruction will be stored on the top of the stack, and it is going to deviate to the interrupt routine. Then after completion of the interrupt routine, it is going to come back and continues by retrieving the top of the stack back into instruction pointer and code segment register. It will continue from the current sequence. So, that is the use of IReturn. Next is interrupt on overflow. So, here overflow flag will be verified. If it is set, then it has to execute one interrupt service routine called interrupt on overflow, that is, so type 4 interrupt. Type 4 interrupt is an overflow interrupt. So, when we discuss the interrupts and interrupt structure, then we will come back again for this what is type 4. So, till then just remember that. So, when type 4 interrupt is to be executed based on the interrupt on overflow, by verifying the overflow condition is satisfied. So, it is going to switch to the type 4 interrupt routine by loading the address of the type 4 interrupt routine into the CS and IP. So, before loading this type 4 address, so contents of the CS and IP will be copied onto the top of the stack, and it is going to load with the type 4 addresses. Then type 4 interrupt will be executed. Then at the end of the type 4 interrupt, IReturn and come back. So, top of the stack will be retrieved again into CS and IP. So, next sequence, next instruction onwards will be continued after this. The last instruction in the program deviation is int n. So, int n, where n is an type of the interrupt to type. So, this interrupt to type n can be from 0 to 255. N can be anywhere between 0 to 255. So, depending on the type. So, for example, type 4. So, if n is equal to 4, it is nothing but int on overflow equal to int on overflow type 4 and int on overflow more or less same. So, likewise any type. So, based on the type, suppose if you use say type 10, then the type 10 interrupt will be executed. So, that means based on the type 10, so whatever address is supposed to be loaded, that address will be loaded into CS and IP by saving the address of next instruction, that is present contents of CS and IP will be stored on the top of the stack, and they will be replaced with the type 10 instruction address. Then it is going to deviate to that. After executing the type 10 instruction, then come back and retrieve the content from the top of the stack, continues. So, this is how the program deviation instructions are being executed by the processor by verifying various conditions. So, today I will stop at this point. We will continue in the next class with some other instruction set. Thank you.